So the explosion makes the snow fall off the building to the left here. And this was a minor setback for the ESA company that is launching rockets that is supposed to lift satellites up to lower orbit. And this is actually quite the huge rocket. It's 2 meters in diameter, so it's not the small kind. And this is happening only 40 kilometers from where I live, and this is something we don't normally do in Europe. It's the only launch facility for this kind of rockets actually in Europe today. So that's about rocket science, but what we are doing today in this video is not actually rocket surgery, it's about tackling another C64. Then this is our last C64, or not last C64, but the last of the C64 from my batch, the batch that I just unpacked. But I do see here the picture is kind of overexposed. I will try to correct that. That seemed like a good and warm color. Maybe a little wrong on the colors, but I do think it's kind of okay. And this one, it's lacking a key. And that's why I didn't pursue this one any further, because it's better, I think, to make one keyboard out of these two. And then I can just pick the other keyboard as spares if I don't have another spare keyboard. And we already opened this when I unpacked. And this is a slightly newer board. There is an X keys weak contact. So there is already some test being done on this keyboard. And it might have been opened too, where you can see here on the screws here, there are some screws missing, one here at least, and the tape has been removed. And this is also and this is also not connected again afterwards. So this will have to be remade in some way. But this is a 250425 board, and it has the slightly newer oscillator circuit, and I think this is the last version before the 466 board with new memory layout where you only have the 2 chips. And this board also have the layout where the PLA is down here, and this is the SID, and it has chips from 84, 35, 35th week, 49th, 52, I think, 52. Yeah, and this is a much newer one because this is made in 89, I think, in the character room. So 52, this is probably, it was released in early 25. Because if this is the 52nd week, they have been producing stuff in the Christmas time. And this also has the diodes that we saw on the other machine, where they have done some protection work down here. And maybe this is done by the guy I bought this from. And also you can see that there has been some work with the capacitors here. This is a gray one, and this is blue, and nothing much else. And also, on one of the other boards, we did have a desoldered 373 circuit. And here you can see that there has been done some rework, and it's actually soldered not to the back of the board or anything, it's soldered straight onto the chip. And this is soldered in, this is the ground wire, and it's soldered straight onto the chip here. So what that's about, I don't know. And it has an 8701 oscillator chip, and this fuse. Is it blown? There are some markings here. My multimeter without disturbing the camera. And the battery is weak on my Fluke. Yeah, it's going all battery on me. And I don't remember what batteries there was in this. Oh, it was a 9-volt battery. And this is one that I got from the insurance company. I don't remember if I have any more spares. I have to check. I did have another one from the insurance company. Very difficult to remove this plastic. But of course I'm glad the plastic was here so that it's not discharged. Yes, now I will check the fuse. Yeah, the fuse is okay. It did have a slight marking here on the glass and also some here. But the fuse is okay. And let's just do a quick test. Yeah, and it seems to be working slightly, but you do have some artifacts on the screen. Probably a memory problem. Can be a multiplexer problem. This board actually has the 257s are most chips. And I don't think I've seen most chips this new before, but these are 4784, so they are in 4884, so they made in 84, and all the other chips here. Yeah, this is the only, and all the memory chips are OK chips, and they are the 3764 variant. Doesn't matter much, most of these are compatible, at least the 4164s. And you can see the screen is picking up some noise, so at least we do know there are some fault with this computer, so we do have something to dig into. But as for now, I will turn it off and I will take the board out and look on the back side. This screw was completely loose. This screw was okay, but this was also loose. But it seems to be original screws, but they are not the normal kind that I've seen before. The other one seems like it's zinc coated, but this is silvery shiny. What do we have here? Is there some rework done here? Except this one, of course. This one looks really ugly, and the soldering here is... this is not good. I have to redo this. And otherwise... yeah, these two. This is the socket that is put in for this character room. Maybe they had this fault where the characters were showing up on screen and they thought it was the character room. It might be, but it sounds more like a memory problem, but this is very weak soldering. So I do have to check every connection on these. And also on this one, I will just have to redo this. And they do have some broken traces that they have tried to fix here. We will keep that in mind. This is the pin that is next to this one. This is a 20 pin chip. So it seems like it's the pin 8, 9 and 10 that is messed with. And I will do some unsoldering on this one. And I will also remove the solder on this one where they are put in a socket. And we can check this chip here if it has been soldered, or if this is a new chip. It is a new chip, so this is changed. But this socket here and the soldering work, I do have to redo that. I do have some fan noise in the background, but my old Weller soldering station that is 40 years old, it has started to make some noises. I do think some of the pads actually was leaving the board and getting sucked into the gun. Yeah, all the pads on this one they're breaking off, so this is turning into a disaster. This is bad. This is very bad. It's impossible to catch this on camera, but these pads here and what's left of this, some of these pads don't have connections on this side, and that is good. But the ones that do have, yeah, I'm not sure how much contact this is making, but this looks bad. This one actually has some. I have to check the other side, of course, because if we break everything here, it will be difficult to actually repair this in some orderly fashion. Yeah, every pin is on that side is loose, and you can see here they are just falling off this. They have to have used lots and lots of heat on this. And yeah, the socket is actually loose. And we have to check the pads on this side. Nothing is sticking to this socket. Yeah, maybe I'm going to look on this through the microscope. I do have a very El Cheapo USB microscope. I will try to connect that and see what happens. Yeah, I've connected the microscope, and this one looks okay. This sort of looks okay. Yeah, it looks okay. This one, what's up with? Yeah, I think that's okay. This one. Yeah. That side, okay. See no broken traces here at all, and here all the pads seems to be intact. This one looks a bit suspicious. There are some solder that is, so I do have to do some cleanup here, but otherwise they look intact. So I just do some cleanup on some of these. I do think I'm going to put the machined socket in both of these. This one, it has this bodge wire here that is soldered to the one pin of the chip. So I don't think I will be able to remove this from the socket. Maybe. Okay, that's why it was... This is maybe the one that was removed from the other board. We did have a board with a missing and desoldered 373. It could be this one. And that is why, because the pin is broken. But the socket is not completely loose. I do have to check here to see where it sticks. Okay. I have one pin that is not desoldered at all. I must have missed it. Oh, this is some fancy repair work. They actually made a socket from two sockets. This is not something I am about doing myself. I have done similar things when I was in need of parts. So I won't condemn anyone from doing that. There it fell out. And here we do see some problems. I'm going to do a bit of cleaning here, so we will be better able to watch this under the microscope. But this does not look good. Yeah, I might also do some from the back side. Like so. And I'm going to turn on the microscope again. This is the one that was going to this point. And it's missing a pad probably. You can see the shiny rest here of the vias that has come through here, but this pad, this pad, this pad, and this pad. So the pads that actually has wire to them, this one I'm not sure, but it probably had a wire on the other side, because I can see no evidence of it being here. So on the other side, this one. I do think all the traces on this side is okay, but we did have a bodge wire, and the bodge wire was on this connection here. I might find a smaller tip here. This was the earth wire with the broken pin, and this one was the one that had a connection. And could be just broken here. Yeah, this one you can see where the trace has been. It's broken. So it's just here. This one is okay. Okay. And this one is probably repairable. You can see there is something left of it, and the same with this. And this one is okay, and that one is not connected. And the last one, it's connected to a via something. This one is okay. Okay, 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 and yeah. The machined sockets is possible to make bodges on both sides on them. I will go and collect some of these sockets and we see what we can make do with here. What we normally call machined sockets is these sockets with the round holes, and this is a China version. I'm going to check that it actually fits. And make connections with this socket, with this chip I mean. Yeah, I think that will be a good fit. And these sockets is actually what I prefer if you have desoldered chips, because these won't be destroyed with if you have some solder left. And you can also see here it's possible to thread bodges and do measurements from this side. So this one will be soldered in like so, and this one we will try to make this bodge here before we put the socket in. I'm not sure how successful that will be, but normally it works just fine. Did have some difficulties with emptying this via with solder. What I did here was that I cleared out this hole, and you have this thin bodge wire here that was used. If I take this really thin wire and just put it like so, one thread into the via and one thread into the chip hole here, and leave it like so. And then I put the socket, and this is a machined socket of a much better quality. This is not the China variant. And I put the socket in after this thin thread, and then I just solder this up with this inside, and then we should be able to make good connection. Yeah, we'll just try to check if this is. Yeah, that is probably inserted. But this socket here, I actually, when I put this in, I pushed out this thread here. So we have to check that that is making connection still. And I also have to put some pressure on to keep the socket in the hole. Now both sockets are secured somewhat, but I'm going to just put this away. And I'm going to solder this up real fast. I do have to solder this from the other side where I'm not making connection here on this side. I can try, of course, to see if the solder passes through. It might work, because if we can make the solder through here, it will be much easier. Yeah, we can solder the other socket as well. The ROM socket is quite easy to measure out because most of the pins is common among all the ROM chips. Here is the one with the wire, and this is the wire from the via hole. And here there was no pads at all. Yeah. How does that measure out? I'm not sure about the ones we were hoping from this side. And this tip on this soldering iron is not very good for this kind of work. And it could be very, very tricky to be able to solder this. I'm not sure how this is going. Yeah, I do have to use the fluke and measure out this. Of course, there are some pins that is not common on all the wrong ships, but all the address lines, except that there are fewer address lines on this room than on the other ones. This is maybe the ship select. This is not connected. This is not connected. So we probably have some fault down here. And let's see on my sheet. Do we have some rooms? This is the data connections, and they should be connected. No doubt about that. So here we have to do some soldering underneath. This will be very trickery. This is connected. This is not. This is not. So it's these two. I have to stick my head in here, so sorry if I obscure the camera. The machined socket has these small gaps between the plastic and the PCB, and that's where I'm soldering now. I make the solder flow out around the legs on the top, and hopefully then it will flow into the vias and make good contact. Did melt a bit of plastic there. Let's see what happened. Yeah, and then it was the one on the other side. And the chip select is the 20. That should not be connected. So it was... This was connected and this was not. And this was also not. That is actually A12. And A12 should not be connected, and this one. Yes, everything there was okay. But on this one, I don't know how to measure this without looking into the schematics. So I just suggest that we test this. There should be no difference from last time. I'm going to plug in this, and we did have a 373 left over from last time, because I do think we left the HCT device in the computer. So is this one. This is an ALS 373. It should be working. I do have one concern here, I see at once. I do have one of these that was not... It's the same as in the room socket. We have to do some soldering from this side to make the solder flow into the vias. Yeah, I do have some of the others that might not be soldered very good in, but let's give it a test. I don't think anything will explode. I do have to disconnect my microscope to get my screenshot camera activated. Let's see if that works. Yeah, we are now ready to do the test, and we are connecting up power and video output. And what we did before was that we have measured out, so we are pretty sure that some things are working here. But this will be a test to see if the garbled screen that we had before, if it was fixed. And the screen is very dark. I do think we have to do some adjustment here for you to be able to see. Just wait a moment. This is far from perfect, but this is the best I can get at the moment. I am totally going to rebuild my system for taking screenshots of these old Commodore machines again, because this is clearly not working. It's very much inconsistent in the picture, and this time I also think that the Commodore picture was darker than it used to be. And using webcams for this is clearly not a good idea, because they have all the automatic things built into them. But what we see here, you can see this picture I've supplied here. It actually tells you what you see on the screen. And I'm not going to comment further on this at the moment, but you can clearly see that there are some fault. There are some shifting, I think, or it might be some missing bits. I have to analyze it further, but it actually seems like the character is rolled over upwards. At least I thought that when I first looked into this, but it might be some that the bits are changed around. So there might be some address or data bus issue. I'm clearly going to measure out if there are some bad contacts and some solder joints or something that we have missed out. So that will be the first step here, and I'm already underway, as you can see. And we have now checked out every connection around the room chip, so I do think everything is quite right here. I can't find anything that gives bad contact or is not contacted at all, or not connected at all, I mean. So I'm just putting the room chip back in and giving this another test to see if we have pushed or touched something that has made the result change on the screen. And it has clearly not, but I'm going to do some adjustment on my TV/monitor and see if I can get the picture a bit sharper. But what I have glued in here as an extra picture is actually a close-up of what you can see. It's not good. There is the same error that we encountered here. It's the same result that we saw on our first try after we did the resoldering. I am actually not sure what I'm going to do now to get some progress in this. I will check now to see if there are some other mistakes that I have overseen, because I do think it's strange that this fault of course could have been with us all along, and that we just fixed the garbled screen where character was showing up randomly, but I do think there is something else at play here, but it's not totally clear to me what it is as of yet. Yeah, a good way forward will be to test with some diagnostic cartridge. Then I will rule out the data and address bus around the CPU, the room chips, and no, not all the room chips, but the kernel and basic. If they have some fault, it will not run the test at all. So it's a good idea. We do the test and see what happens. Yeah, the first we can see is that my new setup here has overcompensated with the light, so it's a bit light, the picture, but we can see the same garbling as we saw before. And with garbling, I mean the garbled characters, not that the screen itself was garbled as in the first try where we had random letters showing up on the screen. As you can see, the computer appears to be stable in all its workings. Of course, the red signs here, it's mostly because we don't have the harness on the ports connected, but that doesn't matter for what we are doing here. The computer is running as it should. So we do have some issues. This room chip is not the issue, and I can of course try with another room chip, but I don't think that will get us any further. So we do have to look into the workings of this, and we have to go to the schematic to see how things are connected around the room chip, the 373, the 4066 and the VIC-II chip. I'm not sure how good you will be able to see this, but this is the part of the schematic that concerns us. And this is the U5 character room. And as you can see, it's coupled together with the two other rooms, but these rooms has the A12 line. And this A12 line is not connected at all here, but I do think the pin is connected to, yeah, just 5 volt. Yeah, you have it here. Pin 21 is connected to 5 volt, so it's just hooked up high. And all the data lines are just connected in parallel. You do have the data bus that goes here, and you have the data bits for each RAM chip. They are spread out there from the data bus. And yeah, okay, I see. This is the 4066 I was talking about, and this is the color RAM. And it seems here that the 4 least significant bits, they are spread out to the 4066, and they are shared with the address bus, and that is because the CPU will be able to write into the color RAM, but the VIC-II chip should be able to read it. But this goes into the VIC chip on different data lines than the one here. So if the fault would have been the 4066, then the fault would have been that the color was wrong, because then there would be garbage in on these lines, and they are just for the VIC-II chip to read out color information for each character. So the data lines, they actually go here and have their own set. So what I must be able to measure out now, and I doubt this is the fault, I would have to measure from all the data lines here to the data lines on the VIC-II chip. That should be quite straightforward. I can of course also double check that the address lines that goes to the 373, because you can see here this is connecting and doing some switching on these address lines, and that is A0 to A7, and they do have some other meanings here on the VIC-II chip and also on the multiplexer chip. And on this board you did have MUS multiplexer chips, and that's not a good thing in itself, because this MUS chip is not the highest quality. But I don't think they can be making havoc on things, but as we saw, we was able to run the diagnostic, so the memory is working just fine. So I do think that the fault will be isolated in this area here, and I will start with measuring and beeping out the data lines from here to here, and also I will go, yeah, I will just check out these connections here, but I doubt that's the fault, but it might be something with the addressing on the VIC-II chip. So that's what I'm going to do now. I will check out these things, because I can rule out that this is working. We can of course try with another character room. It's in a socket, so it's no problem to test. And the character room was changed in this, so someone has been testing that before. So I doubt that's the issue. And this one is brand new. We can of course test that through, but I don't think that's the issue. I think the issue is either with the VIC-II chip, or there is some break or short in the line somewhere. But I don't think it's a short either, because If there would have been a short here or here in the data bus, then nothing else would have worked because the data bus is common and this is not buffered at all. So back to the bench. So we are going to look into the schematics and see that we have all the connections that the schematic tells us that we ought to have. And of course we focus mostly on the VIC-II chip as that's the most crucial, and we have established that everything else on this computer is actually working. Measuring out all the connections on the 373 is a very tedious task and it takes some time. And I actually have to do some of them twice because I was not totally sure that I have measured them right. But in the end, I am very certain that every point just checks out as it should. And this is the kind of task I never enjoy with fault finding. I'm more into the tinkering and thinking of things and not actually measuring out every detail. I prefer to do the most of the work in my head. Yeah, as I've said before, I'm not really into this just chip swapping and testing if thing works, but we have reached a conclusion here that there is nothing wrong with any of the traces, so we do have to consider that the VIC-II chip actually are bad, and that we have, even though we have a different symptom, it could be that also the VIC-II chip is bad. I'm very not certain on that, but we do have to test, and we do have these pairs VIC-II chips, so why not? So let's switch on, and what do you know? This was a huge surprise. Am I really to be proven wrong about this? I was really convinced that this VIC-II chip was actually working and that the fault lie with the C2N chip or some of the surrounding lanes. When we had said that the room chip was okay, I really thought that the 373 was the fault. This is, yeah, it's almost unbelievable. So let's see what happens when we connect the harness and test through with everything in place. Yeah, I don't have the sound on, so even though we have the VIC chip, the SID chip in place, we won't hear the audio, but we have tested this chip before. It's fully working, but I can't remember on the top of my head if this board had the defect CIA U1 from the start, but it probably had. So we might have to do some desoldering anyway if things turns out to be working as it should. When I turn this off and on again, I can see some other artifacts with the video, but it could be the capturing device, I'm not sure. But it might be that we do have some inconsistency, there might be some other failure here. Yeah, and of course we do have an unknown VIC-II chip also, because I'm not sure if this was the one we tested before or this is another VIC-II chip. We have two that is the same vintage in here, so we might be mixing them up. One thing is for sure, we need to do some more testing on this board, and that is before we desolder the U1 CIA. Yeah, just to make sure that you understand what the fault really looks like with the old CIA VIC-II chip, I'm going to show you some close-up that I have taken of this. I just swapped in the VIC-II chip with no other changes. And without the diagnostic cartridge, it looks more like the normal startup screen, but you can see it's really garbled, and I'm not sure if there is a shifting or if there is pixels missing or if some stocking that one of the pixels is. I have not done that analysis, but it's possible, of course, if you look at the character as they should be. This is filmed after I did the initial test, because there is something strange here. And when I went back and looked at my footage, I've changed to this here VIC-II chip, and I couldn't see the first artifact where there seems to be this, where the letters was kind of shift. So I still think that there was something wrong with the 373 chip. And I had this brand new chip. It did test okay when I tested it. I also tested it in the previous C64 and it worked just fine. But I put this back in, and this is a hopeless task. And sorry I missed the footage, but I have soldered this earth ground pin back in, and I do have one pin that is almost broken off. But because this is a machine socket, it was quite easy to actually fit it in here anyway. You have to be more accurate where the pins are placed, because this socket here, it's this exact holes that the pins are going into. You don't have much leeway as you do have in a normal socket, where you do have some space this way, and spring action on the sides is pushing you this way. So it was a struggle to get this in, but I've soldered this in now, and look at this. This is the VIC-II chip that we deemed to be bad, because it had a different symptom than this one, and this was working okay. So I'm changing around now. I'm trying to find another 373, and I'm going to test this 373 in the chip tester again. And remember, this was an ALS device. And the ALS devices do have some difference in timing, but they should have the same load factor and stuff that the LS chip has. But if you remember, when we put together the last C64, we actually put in a HCT device, and I do have lots and lots and lots of 373 that are HCT, and that is CMOS devices with TTL outputs, and it's cascadable with LS logic, but it does have a lower driving factor, so you can't put as many chips behind it. And if that is the case also with the ALS, I am not totally sure. But we are going to keep this VIC-II chip in. It gives a brighter and better picture than this brown one. And this is retakes, because I did a lot of troubleshooting with measuring out all the traces from these, and all the traces are okay. But I had to take a step back when I thought I was about finished with this video, because I was able to get a perfect picture, not perfect, but ceramic VIC-II perfect, with this VIC-II chip and this TTL logic chip. But now I'm back with this and this, and I get a perfect picture. And I'm also going to test this. I have not tested it yet, but I'm going to plug in the diagnostic cartridge and run a complete test. Oh, I must have switched something. This seems like a dead test. We are not, we don't want to do a dead test. Why should it blink even? Diagnostic and set 1. Oh, here you do have some, I won't call it artifacts, but it's a color that is not matching as it should. Oh, there it was. It probably, it might not be entirely stable, but this was not a capturing device artifact. It was an artifact with the computer. So maybe this VIC-II chip is not totally stable, but at least we don't have what we saw earlier with the shift in the signals. And I did have a theory about that, about shifting addresses into this, but I'm not sure if I can recreate that, but of course when we have taken out this chip, we are going to leave everything else as it was. Yeah, we are getting bad U1, and I will turn it off and turn it on again and see if we can see the same artifact with the background color, and that we do. So this is a strange thing. Maybe it's a capacitor issue, because now it seems to be more consistent. And there it's gone. So nothing else changed. This is changing, and it might be, we do run this through the device that converts from SCART and to HDMI. So it might be an artifact with that too. It's very difficult when you have a chain of things that can go wrong. But first thing, I got to get rid of this 373 chip, and I don't think it will survive when I lift it out of the socket. It's yeah, what should I say, the one leg, this one, I do think it will definitely break off. But let's pull it and see. No, it did survive, at least so far. And I do have one leg here that probably was not very well connected. Can that be a solution? And can that actually explain the artifacts? That's very difficult to see. And I don't have a footage that's close enough where I can see if this leg actually was connected, but I have just taken it out, and it is bent like this. So it probably made contact, but I'm not sure. It could be the cause of the bad contact. And we just now plug in the device that was the ALS, and we might also have some bad contact issues around the socket. We don't know. But here you can see the artifacts with the shifting of the letters is back. So this one is definitely causing that in some way. And I will just go and get a new one. And when I said I was going to get a bunch of these, I was not lying to you. This is a 74C 373. This is a 74F 373. This is a 74HC 373. This is a new ALS, but it's another manufacturing company than the older one I tested. This is a 74LS 373, what should originally be here. And this is what we used in the last one. It's a Philips HCT 373, and I do have a whole pipe of these. And this is what I'm going to test with first, because this is what we get working in the other one. The other one was a 407 board, and this is a 425 board. And the only difference I know that are on this board is inside the clock oscillator circuits. Otherwise, it's smaller changes. You can see the difficulties with getting chips into the machine sockets. There definitely are some artifacts here. It's not the same ones as the last chip. Actually, no, they are about the same, so there might be some contact issues here, or there might be some signal level issues. I was trying to just see if there was some contacts, and I can't say that. So, disconnecting this and putting in what should be there, an LS device. And these are all unused chip, my old stock from back in the day. Like so. And here you can see this original artifact is back. Or not original, what we had with the other LS chip, ALS chip. I will try to wiggle it a bit in the socket. No, it's the same. And let's try another ALS device. Like so. And there the artifacts are nearly gone. You can see there are some instabilities if you look up on the S and C up in the headline. And you can also see it's mostly visible, but there are some artifacts here, but not as bad. And we can try the HC chip. The difference with the HC and the HCT is that the HCT can guarantee CMOS levels. If you do have some chips that is working marginally within logical levels, the HC device is not very good at that, and it's also a lot less driving than a normal LS. This is definitely the best picture yet. Of course, my screen capture is not perfect, but all the letters are stable. So we put that aside. And here we have the little brother of the HCT, a very short-lived logic family member. It's the C64C70C, and that is really a CMOS device. They didn't mark what's pin 1. Yeah, maybe they did with a short notch here. Like so. Oh, I definitely think that we have some issues here. So the C, I can see where that was short-lived. It's not entirely TTL compatible, that we can say, or we might say. And this is the F device. The F chips is the fastest family of them all, and it should be compatible, except that the timings are tighter. Oh, I don't know if this has been used before, but I do have some legs that was bent inwards, but it's not soldered at least. So and this is also totally fine, so I will say the picture quality, at least apparently, is even better than with the C chip, the HC chip I mean. But I will do another test, and that is to put back the original chip to rule out that there is some, just bad contact somewhere. Where did I put that one? It was an ALS chip. I think it was this one, yes. And it's back. So I think we can rule out bad contacts on the socket, and I do think we can say that we do have some compatibility issues. But what are causing them? I'm not sure, but I'm trying again with the HC device. This was the one that was giving the second most perfect signal, and it's consistent. But let's run the test fully out with this chip that does not give any artifacts at all, because we do have some issues here with also this keyboard connector thingy. Yeah, probably I was able to hang the machine now. No, it was okay. Yeah, it still says that
the keyboard or control port is bad.
The sound chip we have tested many times, so I'm not going further into that. Make sure there are no shorts, and I'm going to make sure that there is no bad contact that can cause this either. We did have this on the other board, where we did have these diodes, but we lifted the diodes and we have to change the 6526. But these diodes was added at the time, and if they have destroyed this chip, or if there is some other things, it's very hard to judge. As we can see, the picture came back and is stable. We will just leave the test running and see if the CIA1, if it's still marked as defect. And it is. It's the same as last time. Yeah, this is a strange one, but can we make a conclusion? Absolutely not. I have to dig into this. I will have to test this VIC-II chip with in another board to make sure. And also we do have to dig into and identify if this chip is bad or not. We might have to desolder some of these diodes to see if they can make this. And I don't know what to make of this board. There has been some changes of capacitors also on this board. I never seen one of these black ones together with these, or I might have. But these solder joints here don't look new, and no one else of these seems to be changed. And we did see that this chip is draining its signal from the address lines. There might be some issues where there was some logical level that was just marginal. And on the address lines, a lot of chips are connected all the time. You have the PLA, of course, that is decoding address lines. You have the CPU. You have all these ROM chips. You have the RAM chips via the multiplexer, of course. And multiplexers, this is the multiplexers. And you also have the CIA chips that is also loading the address bus all the time. So there might be a loading issue that when we are putting this ACT device or F device or something on the bus, it's draining less. I'm only speculating here because this is a totally new and interesting unknown fault, and we are going to investigate this further, but it won't be in this episode. We do have to go on to this with a clean head, and we do have to do some studying on the schematics before we dig into this.
Yes, first, sorry for the bad sound quality again in a video. I tried to fix this, but there always are some issues, and of course it's my fault, and I need to do some quality control of this. So I am going to redo again all my equipment back on the desk, and I'm also going to change the computer that I use as the recording device on the bench, because I made this setup to get less work in post-production, to get out more videos with good enough quality, and I'm nowhere near that. So sorry for that. And even with my front setup where I record screen takes, and when I walk through the schematics here, I even then managed to use the wrong microphone as the source. So I make mistakes when I do these videos, and sorry for that. So I'm going to use the time before my next video to fix the issues I know I have. So I'm going to change the recording device, and I'm also going to do something with my microphone setup so that I will get more consistent sound. So sorry for the poor quality, but at least this video do have some interesting topics. What we are experiencing now with this VIC-II chip and the 373 chip on this 425 board, it's really interesting, and I'm going to test this chip now. This is the scrap board that we fixed. It do have the 373 in a socket. So I'm going to test with this board, and if I can't recreate the issue, I'm going to dig and find another 425 board, and at least I'm going to change the VIC chip. If I'm going to desoldering a 373 to make a complete test, we have to see. We have a 425 board here. We need to find the issue with that board too. So it's only to test if this is a situation that only occurs in special situations. And of course we also have the 6526 chip, the CIA, to look into on this board. So that will be the next episode, but it won't be next weekend I release that video because I'm going on a travel now and I have to review this setup. So sometimes during the Easter holidays I'm going to release a new video, and it will be about this. So thanks for watching. Hope you enjoyed the content, even though the sound quality was kind of poor. So please review some of my older contents. I have over 200 videos now out there. Some of them might be good. And watch my C64 playlist. There is a lot of good information there. So until next time, take care.